Yes.
Welcome back, everyone, for this executive panel on memory and storage for scaling AI inferencing. We're really excited to have this, and we thank NVIDIA for sponsoring this session and making this happen. There'll be, in this presentation, each will talk initially. We'll have some Q&A with these folks, and there'll be an opportunity for any of your questions. So I'll have a mic out there, and you just come over, and we'll field those. Also, you're going to see an AI tool that will have kind of highlights of what's being presented kind of live. That's provided by a tool called Rosie from Synopsys, and we're excited to have that as a kind of we're testing this out, and if you like it, we'll probably then continue that for next year at FMS. So we'd love to have your feedback on it. I'd like to introduce our members on this panel, starting on from left to right. We have from Kioxia, Rory Bolt, who's a senior fellow at Kioxia America and leads the forward-looking technology and storage pathfinding group for SSDs. He has more than 25 years of experience in the data storage systems, data protection, and high-performance compute with a pedigree from marquee storage companies. Rory's been granted over 12 storage-related patents and has several pending. He has a degree in computer science from University of California, San Diego, and we welcome you.
Thank you,
Rory. Let's see. Oh, next we have John Mao, who is VP Global Business Development for Vast Data. He's a technology executive and leader with over 20 years of cross-functional experience in early and growth stage technology companies. John's currently in that role that addresses business development strategic alliances at Vast. And he's focused on enabling AI, data analytics, and cloud use cases for large data organizations. Prior to joining Vast, John led the product management and product strategy teams across a wide range of technology verticals, including cloud infrastructure, network and application performance management, custom hardware, big data analytics, storage, and hyper-converged infrastructure. Starting his career as a database engineer provided an on-ramp for him in the world of kind of unlocking, the whole meaning and insights of large data sets, and he has a passion for this whole field of AI today. John holds a degree in computer science from the University of Texas. Welcome, John. Let me see here. Next we have Sunny Kang. And Sunny he's VP of DRAM technology at SK Hynix, has over 20 years experience at SK Hynix. He successfully has led numerous high-impact initiatives as a seasoned expert in DRAM planning and new product enablement. His role as a JEDEC representative contributing to memory standardization and ecosystem development has been a cornerstone of his professional journey. Since joining Hynix America, he's been leading the DRAM technology team, overseeing the future pathfinding and roadmap alignment with key customers like NVIDIA. His responsibilities include new product enablement, customer technical support relating to mass production quality. Welcome to our panel. Next, we have Vincent Su, an IBM Fellow, and CTO and Vice President of IBM Storage. His responsibilities include the IBM Storage Technical Strategy, Future Storage Technology Research, Storage System Architecture and Design, and Solution Development. He's leading IBM storage strategic initiatives to support IBM hybrid clouds, along with how data, AI, and cybersecurity mesh and integrate into those storage solutions. He's devoted his entire 30 years of his career on storage subsystem research and development. He is a master inventor at IBM. He was named a distinguished engineer and chief engineer for IBM Enterprise Storage. He was also named CTO in IBM for IBM and Disk Storage, leading the whole storage technology council for them for all IBM disk storage products. He's been a fellow since 2015, and since 2023, he represents IBM in the CEF community governance board. He was appointed to IBM's technical team member this past year, and he leads IBM Storage to deliver the first content-aware storage subsystem to accelerate AI data processing and inferencing. He has degrees from University of Arizona, Masters of Science, Computer Engineering, and an MBA from Eller College, University of Arizona. We're honored to have all of them as panelists, and also honored to have from NVIDIA, John Kim, Director of Marketing, who will be leading this panel. So I will turn things over to John.
Thank you, Jay. Welcome, everyone, to Thursday, the third and last day of the Future of Memory and Storage Summit. We're very excited to present a panel about AI, and not just about storage, but about how memory and storage can help scale AI inferencing. So a quick word about that. Just a few years ago, if you asked me, or I think a lot of people at NVIDIA, and said, how much storage does inferencing need? The answer would have been, it doesn't need storage. You put the model in memory, one model fits in one GPU memory, and you run it. People ask one question, they get one answer, that's it. You throw away the rest of the data, you start all over. No storage needed. Lots of storage for training, none for inference. That is dramatically different today. You've seen in the earlier keynotes, you've seen in the sessions that today inference needs storage and inference needs memory. So what happens is the models are getting bigger. Many of the models don't fit in the memory of one GPU. So now you have to figure out how to scale it across one model can run across several GPUs, or has to run across several GPUs. Their inputs are getting longer. People are not just asking questions like, is there going to be a kiss cam at the FMS keynote, and should I hide in the audience? And be careful of that. But now people are asking, well, give me a summary of the most important information from all this code, from these books, from these movies. So the input might include videos, audio, books, part of the internet, all of the internet, could a code base with 4 million lines of code. These could all be part of an input into an AI model during inference. The outputs are getting more complex. You're asking AI models to create not just a simple answer, but to create code, to create videos, to create an itinerary, create a presentation, PowerPoints, PDFs, entire fake movies of cute animals jumping on a trampoline, or well, maybe they're real, or something like that. So the point is the outputs are getting more complex and longer. The agents, the reasoning, and the research models mean that there's no more one shot. You have multi-turn inference. Question goes in, it thinks about it. The model maybe invokes another model. It researches, it grabs more data from the internet, from a RAG database. It searches a vector database. It gets more data. It asks itself questions, and it shows what it's doing, how it's thinking about it. Agentic AI means it has to remember parts of the conversation. It gives you an answer. You ask a follow-up question. It gives you another answer, another follow-up question. Every turn of that, the input and output is getting longer and longer because it has to remember. It has to keep that information somewhere. And the answer is that somewhere is probably going to be some kind of memory or storage, or both. So we're going to start out with the panel. And I'd like them to start out by addressing, each panelist is going to present one slide and talk about what are some of the key memory and storage challenges to increasing AI performance and scale. especially on the inference side. Okay, so if we could start out with Vincent.
Okay. All right. So, I didn't know I was going to go first, but hi, everyone. I'm so glad to have this opportunity to talk about the storage technology here. So, throughout this conference, you hear a lot about how do we make storage faster, use hardware and softwares, and how do we make the memory, local storage, external network storage all combined and things like that. Those are very, very important, by the way. Those are very, very important. All this technology is needed because the data is getting bigger and the expectational latency is even shorter. So we're always joking about in the past, you have a big, large data, but slow. And you have small data, but fast. But with the AI inferencing, you need large data and fast. Okay? So all this is true. All this has happened, and the industry is driving very hard to make this work. I want to introduce a new concept here. In addition to just making brute force try to solve the problem, make this pipeline faster, make the I/O faster, make the protocol faster. What if the new storage is smarter? Instead of you process all the data, because a lot of data you really don't need to process. If we can teach storage to be smarter, maybe you just process the relevant data. So to solve the problem is, why don't you process less data? Why don't you reduce the data movements? Why don't we figure out a way to yield the same accuracy by using the less data? And that's really the spirit of content-aware storage. That, the storage. We're talking about. I was in storage. I've been in the storage business for 30 years, and when I first started, the storage basically just, when people talk about storage, people literally talk about the hard drive and tape, right? Then we talk about the storage, really the data storage. So we have file and objects and block. But going forward, the storage should take on the responsibility as information platforms to help us to provide the right information to the application. So introduce two concepts. One is the content aware. The other one is context aware. Not just all the content are relevant to the particular context. That the combination of these two, they will serve all kind of diverse hybrid workloads, hybrid use cases, and hybrid location as well. Because this kind of things that inferencing happen everywhere. How do you build a consistent platform across the hybrid cloud and allow all the inferencing to be able to collaborate with each other? I think that's the challenge for the storage. Thank you.
All right, thank you, Vincent. So part of the answer is hybrid storage, and also maybe if you're more efficient, you don't need as much storage or memory. Okay? I'm not sure all the vendors would like that answer, but let's hear from Kioxia.
So actually, sorry, when I was talking to my boss about this one, he said that, are you sure you want to propose this idea to reduce the storage consumptions? I said, trust me, the world will push us to do more storage.
Okay, well, so I think efficiency often wins out. Rory, please give us your perspective.
All right. Well, at Kioxia, we develop solid-state disks, and we look at all of the AI workflow and the different needs across the spectrum here. And so, as we saw in the keynote, our theme is one size doesn't fit all here. There are going to be essentially optimizations for the different phases of AI. Data ingestion and training, largely solved at this point, right? They do need very high throughput, large capacities, but our focus, as is the focus of this panel, is truly on AI inferencing, because this is where we see the most diverse demands on the storage, as well as the most growth in the storage. So if you could click forward there. Obviously, you have these large language models that have been developed at great expense, and you need to quickly be able to load these models into the inference servers and to be able to switch between models and mix of experts types situations. But as was already said, these models are growing. They're growing at a pretty incredible rate. And we do see what we term memory walls emerging in terms of the capacities of the HBM memory subsystems of these GPUs, that We are developing new types of media and new types of devices to try and address those in conjunction with NVIDIA on the SCADA and StorageNext initiatives. But fundamentally, the largest growth opportunity that we're seeing right now is in retrieval augmented generation, which is supplementing contextual information from either updated data or private data and feeding that in to the LLMs to do generative AI. And this process of creating embeddings of your private data and the vector databases associated to retrieve that relevant data and feed it back into the LLMs is truly a multiplier effect. And as we shift from textual AI applications into multimodal AI applications, we see that multiplication increasing dramatically there. So sort of in closing, from our perspective, one size doesn't fit all. We see diverging needs for very, very high IOPS, low latency devices, as well as these massive devices to make the implementation of the data lakes that are behind all this more space efficient, more power efficient, and more economical in deployment. Okay? So that's our perspective. Thank you.
Rory, thank you. I think I want to reiterate 3 great points you made. One is that training still needs more and more storage. We're not focusing on that here. I think it's solved in the sense that people understand what type of workloads you need to support training, but that doesn't mean it's not growing. It's still growing.
No, it's growing.
Second, RAG is a way that's converting a lot of enterprise content into searchable, indexable databases with meaning that can be applied to AI inference. So that creates a need for storage. And I forgot to say, and you mentioned at the beginning, that the models are growing faster than the amount of memory on the GPU, right now at least. So that's part of what creates this memory and storage challenge here around inference. So let's hear another perspective. Sunny from SK Hynix. Tell us
Hi.
what you think.
Good morning. Today, I just want to talk about what SK Hynix we are doing for AI memory solution and storage solution as well. So the center in a triangle, it shows memory and storage hierarchy. So we do DRAM, and we also do storage solution as well. The left side of the slide, which shows what we are doing for DRAM solution. So in the past, DRAM was just one of the commodity solution. It's kind of passive component, but defined by JEDEC definition, and everybody use same single part number for single platform. Everybody was same. Take it out the memory solution from SK Hynix, you can put it instead of the Samsung or Micron. That was definition of the memory, DRAM product in the past. But now it's changing a little bit. So, for DRAM, we have various products. And for data center, for example, we used to have the RDIMM for entire, bottom to top tier. But now we have different kind of the RDIMM for single platform, different, the speed grade, and also we have the other definition like SOCAMM using LP memory for server application. That might be keyword, future memory, future server memory solution for data center. And also we have MLDIMM, the much faster memory solution, but it consumes more power. That's kind of advantage and disadvantage. But anyhow, who is looking for high performance, really high performance, the data center solution, MLD might be a very good, candidate. So that means we are having diversifying memory solutions. And also, as everybody heard about it, HBM, it becomes really, really hot, product nowadays. So every, the data center working for AI solutions, they are looking for HBM-based, the accelerator or GPU, like NVIDIA. They are doing very well with us, actually. So now, today, we are doing standard HBM. So like HBM3 and HBM3E. Now we are moving to HBM4 now today. So, but in the future, the following, the platform. So they are, not only platform, our customers, they are very interested in customization solutions. So, but that's kind of the hybrid customization. Only they're going to customize the base die. The core die itself, it should be, JEDEC standard core, So having one core die development, have various different kind of the base die. So, the NVIDIA and other, the accelerator, they're going to use their own solution. That we call the custom HBM. But in the future, it may have, full customized solutions, but that's very initial stage today. And also, the right side of my slide, it shows our, the storage, lineup. So today we have the TLC and QLC. That's very, the classical, storage solution. But we cannot say it's fully, optimized for AI solution. So now we are trying to have it. We just kicked off the project to have, AI optimized in storage solution. We call it U-tier solution. So it's gonna have very high performance, like 15 milliops, performance with PCIe Gen 6. So, and also, as we announced yesterday, we are working with very high performance, just memory-like operation. We call it HBF, not HBM, high bandwidth flash memory solution. So also we are, look around. That's very initial stage, just kind of product concept of that. So we wanna, you are very interested in develop that kind of product future concept of that. Okay, thank you.
Thank you, Sunny. So a great point that you made is that there is a hierarchy of storage or memory and storage for AI inference. And we see that people are using different levels. They need different types of memory or storage for different types of applications. As you said, with HBM, maybe in the GPU, and then you might have CPU memory. And there are different kinds of CPU memory. And then you have high performance flash, or maybe this new type of high bandwidth flash. And then you have perhaps TLC flash and then QLC flash, and some flashes for performance, some flashes for throughput, some flashes for IOPS, and maybe some flashes for archive and long-term storage. Okay, so that's very interesting. Okay, let's hear a perspective from a storage solution vendor or an AI operating system vendor. John Mao, Vast Data. Please tell us what you think.
All right. Don't click yet. So,
okay.
I'm not sure if anybody, if everybody here has heard of Vast, but I'm just going to give a quick overview of who we are. And I think a lot of what these gentlemen have said, we are a systems provider that applies a lot of what they just mentioned, and we partner with a lot of the vendors here at the show to build a new type of data platform. So Vast Data has been around for almost 10 years now, and the founder and CEO of our company founded the business on a single premise, and that premise was he wanted to help reimagine how organizations store, manage, and use their data. And what evolved from that vision that he had is kind of unfolded over 3 acts for the company. The first act of the company was almost 6+ years ago, where we launched a brand new type of scale-out file and object storage system that was 100% based off of NVMe flash. We were one of the first early pioneers to use QLC, quad-level cell SSDs, in a reliable way with the resiliency that enterprises demand. That delivered all kinds of new levels of scalability, new levels of performance, new levels of economics. And that served us very well. A few years ago, we moved into act number 2 for the company, which was to start to introduce a better way to manage data. A lot of our customers are deploying petabytes, hundreds of petabytes, and we even have exabyte scale customers deploying exabytes of our systems within a single data center today. And the manageability around this came down to how do you better understand metadata at that scale, right? In a simple way, how do you understand the types of information, the types of unstructured data, the attributes of that unstructured data in a much more simple way at scale. And now, most recently, we do a lot of work with NVIDIA around this topic, is how do you now better use the data, especially from an unstructured perspective, more meaningfully? And this is where, over the last couple of years, we've seen the rise of AI really bring new meaning to what does using your data mean? How do you extract new insights? We've been partnered with NVIDIA to kind of showcase a lot of these capabilities, but using this data now means applying AI to semantically understand things like documents, semi-structured text, videos, images, et cetera. When you put all those things together, the interesting thing when we talk about inferencing from an AI perspective is that it now has a whole new set of requirements from a data, from a storage, from an I/O perspective, because there's new technologies that are required. Unlike in training, which is, resembles a lot like classic HPC types of workloads, pretty well understood, fairly monolithic, very more batchy oriented, AI inferencing is a completely different animal. It is typically a workflow. It is a pipeline. It is a series of steps that happen, mentioned by, I think it was Rory, your slide, right? Talking about the emergence of new technologies like vector databases that bring new requirements from an infrastructure perspective, from a storage perspective, from a data perspective. So I think the slide was not for you to memorize as an eye chart. If you just click through a few times, just to kind of help people understand, we work with many, many organizations implementing that. I can click a few more times. There's a lot of arrows, and this was simply to portray what I just described, which is that the life of data that flows through AI inferencing is not linear. There are things now like long thinking inferencing functions, multi-turn inferencing that actually causes this recursion and happens continuously within that. So it's a much more complex environment, but it's also exciting because I think it allows this entire industry to start thinking about new solutions to solve these exact types of problems. So.
All right. Thank you, John. So I'd like to, it's a good point that, the purpose of storage started as, store the data, protect the data. Now it's how to get more value out of data or use the data more effectively with AI. So let me take some questions to the panel, and then we'll go to get some questions from the audience. So the first question for the panel, and there could be different viewpoints. What's going to be more important for scaling inference, memory or storage?
Let's vote. Let's vote.
Any of you can start.
Anyone want to guess what a storage vendor is going to say? We think that from a TCO perspective, just with the explosive growth, that storage is going to be dominant overall, right? From a bit capacity standpoint and from a bit cost standpoint, the economics, we believe, are going to drive it towards storage. I mean, make no mistakes, memory is important, but there are limits to how scalable memory can be that are roughly an order of magnitude or more constrained than what we can do with storage.
So, well, actually, let me ask Sunny. Your company offers both.
Yes,
so
both of them.
What's your perspective?
Actually, the AI itself, for end customer like us, the most important thing is, immediate response. Real-time response is the most important thing it is. In order to have it, the memory, like very high performance memory like HBM, is a very essential component it is. But without having storage solution, there is no scalability, such a cost-effective solution. So in that perspective, we need to have the combination of the good balance of the combination between memory and storage.
Vince?
I think often about also how large scale you're talking about, right? Mm-hmm. So, 12 months ago when I talked to a lot of people inferencing, they're like, well, storage is almost irrelevant, right? Because everything can fit in memory. But once the enterprise start to scale their inferencing operations, they still require high performance memory, don't get me wrong.
Absolutely.
But they just cannot afford it. I think that one of the conversation in GTC, people ask NVIDIA, why don't you guys champion put all the data in memory? And I remember Kevin's feedback is, would love to take your money, but kind of feel guilty about it. It's just unrealistic to expect that try to put everything in the GPU memory. So the real implementation is how do you right size that? How do you make sure that this is, how do you right size to make it, cost efficient and make it performance efficient?
And if I can add on to that a little bit, because this cost thing is really an issue, is particularly you saw me mention vector databases, and the most common deployments of vector databases right now is probably HNSW, right, which is an all-in-memory vector database, and we developed a technology that we've open sourced, just trying to promote the use of SSDs to address the scalability problem. Because if you look at the requirements on memory for 100 billion vectors in a vector database, using HNSW, it's going to require around 100 terabytes of DRAM. And I'm sure Hynix would love to sell that to you.
Yeah, yes, we do.
But there has been a lot of work done on trying to make effective use of high-speed storage, SSDs in particular. Microsoft did seminal work on DiskANN to reduce the memory footprint required for these large vector databases. And you think, who really has 100 billion vectors in their vector database? Well, I actually talked to a customer that has a trillion vectors in their vector database. So these astronomical numbers, they're becoming real life now.
I mean, this is a classic computer architecture problem, right? That's existed even before AI took over. I mean, the bleeding, from main memory to storage to remote storage, this kind of hierarchy has existed for forever, right? I mean, since the early days of computing. I think that there's going to continue to be innovation at the memory level and more and more requirements around that, just because of what you said in your very first slide, right? Around the opening, around just some of the context sizes that are growing in length. Like there's just model sizes getting larger. There's going to be more and more requirements there. But part of the reason, like Vincent said, I mean, at scale, when you're talking about inferencing, and like you mentioned, you can't rely solely on memory because there's also persistence that's required that is critical if you're running anything in production. And one of the fascinating things that's happened recently, right? Because when we talk about storage, there's also this debate then between like local storage and remote storage that often comes in. And from our perspective, obviously at VAST, we're a remote shared storage platform in that sense. And one of the super interesting things that's happening over the last 5 years is that's getting more and more blurred as well because of faster and faster networks, right? So networks have gotten faster, which make the local SSD versus remote storage conversation get even fuzzier for reasons that the performance gaps are still starting to converge as well.
Yeah, great point. So at NVIDIA, part of what we've done for the memory issue is we have a technology called NVLink that links multiple GPU servers together in one domain. So the memory domain can be as large as the combined memory, HBM, of all those GPUs. But it's much bigger, but it's still not big enough to hold that trillion parameter, or probably even the 100 billion parameter, vector database in memory. And that memory is usually used to hold the models. And then you can have separate use for the database. So we can't fit it all in memory, even if we'd like to. Let me ask a related question to what we just asked. And so if we have to have a hierarchy of memory and storage, not the hierarchical, navigable, small world, vector database, which is also important. But is the best way to use storage in this case to treat it as storage, as a separate storage tier, or try to make it an extension of the memory tier somehow?
Go first. I mean, personally, I think it's an implementation detail, and there's advantages to both, right? So obviously, if you can make it extensible from a memory perspective, that might buy you some transparency at the application level. But we've also been doing a lot of work, for example, with like KV caches and also other kinds of GPU direct access, where underneath at an implementation level, we're still running a file system, we're running an object storage system. And wiring that up to be able to provide that back is kind of irrelevant. What you need to worry about working from the file system level is understanding that access pattern. So being able to organize how you store things from a directory, POSIX level kind of file system or an object-oriented, that scaffolding, that structure is actually as important. And you can oftentimes get very, very good performance in that means as well. So there are advantages to kind of having that addressability, either be memory-like or file system-like.
Okay. Other thoughts on that?
So storage hierarchy is not a new concept, right? And every time I talk to customers, they say, why don't you put the colder data in the cheaper storage, hot data in the high performance storage? They were like, yeah, but who have time to do that, right? Nobody has time to do that. So one of the
You mean no one has time to manage it and move the data?
Well, nobody forget about manage. Just initially put the data in the right place at the right time. So we always, when I talk to customers, I always talk about, why don't you classify your data? Who has time for that? Because we generate data faster than we have time to even classify it. So this idea about this seamless tier is very important concept. One of the IBM sort of older product called AS400, but even now they already have this concept called single level store. What it does is the application actually have no idea. They actually put the data in different tiers. They actually always write to the memory and the backend, the OS, if you will. So put the data in the right place at the right time and be able to monitor the activities, move them all the way to even tape. I know many of you probably didn't know what tape is. But I think that eventually the world will evolve into this way, because how do we make the application easy to consume the underlying technology is the important thing. Sure, today I can guarantee you there's a huge optimization we can do for file or block or object storage. Those are very important, but I think that the industry should look into how do I make this consumption of this easy.
Yeah, could I add one more thing? So I think the interesting thing about the storage hierarchy is that entire mindset from what we've seen recently, because in this AI era, it's kind of turned that mindset on its head sideways. And the reason for that is when you're putting things, classically, if you think about IT and infrastructure, you think about storage, that last tier of storage, right? Tape, for example, in the extreme, is usually for data protection. It's for safekeeping. It's for keeping your data in a very cost affordable way as possible, and it's about safekeeping. That logic doesn't hold in the world of AI, because if you're trying to extract insight and understanding from that, you can't have a fleet of GPUs waiting for a robot or a human to go load a tape into a tape recovery system to then go analyze. It doesn't work, right? They could chew through that footage, that tape in very, very small amounts of time. So that entire thought process of how you do it, I think for this entire industry should be a good thing, because the foregone conclusion there is that you need to put more and more of your data online in something that is going to be ultimately more accessible to a lot of these intelligent algorithms that are starting to come out, and obviously faster and faster compute that can access it as well.
Yeah, one of the technology that we infuse for those kind of used to call the colder data is be able to leveraging all this AI capability to make those data accessible instead of like try to go through to scan all the data in a tape or some object storage. You can immediately get to the right data at the right point. I mean, this is what metadata is important. Be able to vectorize this data is important.
So, when I look at the storage hierarchies, the thing that you have to really take into account is that typically there's orders of magnitudes of difference between access times, the different layers in the hierarchy. And so it's really, really important, I think particularly in the AI workspace with the GPU costs being so high. Sorry about that.
You're saying our GPUs are expensive?
Who would have thought?
Well, we want to keep them well fed. I think we can all agree on that.
You want to keep them well utilized.
We want to keep the GPUs busy.
And so you need to have cooperation with the applications. We're seeing a lot of work in this area to mask the latency, right? And so one of the true advantages the GPUs have, as opposed to traditional hierarchical storage management systems, which at this point have been around for 40 years or more, is that they have an extreme number of threads, hundreds of thousands of threads, and very, very low context switch overhead. And so they can afford to essentially issue these relatively slow, well, not relatively, slow IOs compared to HBM, but mask the latency through deep pipelining and context switching to other jobs that aren't, or other operations that aren't IO bound. So I do see that the fundamental difference that I think is going to enable a efficient use of this hierarchy of storage is that ability to deeply pipeline and mask the latencies, because I will admit to working on HSM systems backed by tape 30 plus years ago, and you can make it transparent to the end user, but essentially from an operational standpoint, but you can't hide that latency.
Okay. So Rory, that was a good point. So you're saying that you, in some cases with storage, you may be able to mask the latencies by using lots of parallelism and maybe deep queues. Okay, all right, very interesting. And one follow-up on that for Sunny. You mentioned high bandwidth flash. Do you think, and I didn't preview this question for you, but do you think that's going to be treated more as flash storage or as memory? Or they're going to make it look like memory, or it could be both?
I think it's too early to, say about what kind of the functionality it will be. But at the moment, the concept of HBF is more like memory kind of application it is. Mm-hmm. So storage side, I have no idea how to use it. But basically HBF, we are going to use TSV, and stacking all the devices all together. It means parallelism. So we are going to have very high bandwidth. So that level of bandwidth I think is more likely for memory like operation it is.
Okay. So HBF will have the same type of bandwidth as HBM.
Yes, so something like that.
Maybe not the same latencies, but the same but similar bandwidth.
Latency in no way to achieve DRAM bandwidth and DRAM latency. Okay. Physically, it's not possible. Yeah.
All right. All right. Let me take another question to the panel, and then I think we'll go to audience questions. So, and this is a question about security. If we're talking, how do we address security in the world of hybrid cloud AI when we have different tiers of memory and different tiers of storage? How should we address security when it comes, to this? Some people may be racing for AI and say, "Oh, security can come later," but eventually, AI has to, well, preferably now rather than later. AI has to have security too. Thoughts?
Yes.
Okay. Yes.
I think. I mean, it's a very broad topic. I can tell you a little bit about the things that we're doing in our small part of this ecosystem, right? From a storage systems and a data platform systems perspective, a lot of the challenges we're seeing from an enterprise market perspective is, this technology is proven now from an AI perspective, but going into the enterprise production environment, security is the number one thing holding them back, right? And part of that is because when you think about, this has nothing to do with like the underlying hardware components, but a lot of this is just around operationally. You think about how most enterprises secure their data, it's usually at a data layer, right? So you're talking about role-based access controls, you're talking about tying things to user groups, right? Tying access control lists, et cetera, et cetera. I don't think there is a standard in the industry yet that defines how that maps into the world of things like embeddings and vector databases, and how do you enforce that? Is there a standard way to do that? How does IT maintain control? So if you imagine a scenario where you're an organization, you have 1 million documents, those documents today are very much permissioned to individual groups of users, right, within your organization. How does that now get translated when you start to feed that through some of these AI pipelines? On the output side, how does an LLM, how does an agent, how does a reasoning model reinforce some of those permissions back through the other way? So there's a lot of work in that area. We're doing a lot in our space, but at a macro level, that's an open question right now for the industry.
Vincent, thoughts on security?
Oh yeah, this is one of the major problems in the Gen AI, if you will. So first of all, today, how people do Gen AI today. And the general practice, they copy data multiple times. And that raises the first security problem. Once you copy the data, you sort of lose control of the access control of the data. And I have seen the people copy data like 3-4 times. It's great for storage business, by the way, but it's really horrible for the security. The second problem is, even though they can somehow kind of control that, and once the data being vectorized, put in the vector DB, now I don't need to be able to see Sunny's data, but I can somehow get the insight derived from Sunny's data, because Sunny's data is the vector DB that everybody share. So one of the things that my project is doing, the content storage is doing, is make sure that all this first of all, we don't copy data. Second one is the vector databases, the vectors and embeddings, make sure they are consistent with the data access control. So I can ask LLM all I want, but I'm not going to get the answers that derive from Sunny's information that get vectorized. I think that this is a very important topic that if you want to prevent the scenario of a Skynet or Terminators, this guardrail for AI is very, very important. And this is just in the beginning, especially that when you talk about agentic AI, the agent has the authority to start to executing the functions, not just give you a suggestion, assist you. And that's even more important to put the right safeguard around your AI.
Okay, so we want to make sure we don't have the right safeguards so we don't end up with the Terminator, but also we don't have data privacy breaches.
Correct.
Rory, what about, your answer, plus also I'm curious from a security perspective, what you're seeing on the SSD side. Is everyone encrypting everything now with SSDs? Or?
Almost all drives support line rate encryption at this point in time. We are seeing movement towards per client keys, so private keys on a essentially tenant basis, because confidentiality is extremely important, right? So that's sort of at the device level, but going back to the vector database, because once again, this is an area that I'm actually researching right now. We have, like I say, our open software ISAC vector database and a search algorithm published. As you mentioned, when you're going over your corporate data and creating your embeddings and vectorizing it, you can vectorize it along different dimensions. And it may be more space efficient to have a single vector database with higher dimensionality than to have multiple individual vector databases of lower dimensionality but segregated. And that's actually the way we see things moving, is towards separate vector databases to sort of partition the derived information that can be obtained across these embeddings.
So you can't use higher dimensionality to also capture more security or access control information. It's better to have more separate lower dimensional vector databases?
It's technically possible, but it's sort of easier to enforce if you split the data.
Absolutely makes sense. Okay, I'd love to go to some audience questions here. So Jay, if you could, you have a microphone. If you could help us get some questions.
I do, and before I just start roaming around to your questions, I have already received several questions that I'm combining into one here. Okay, so this conference of FMS addresses the full spectrum of memory and storage. And one of the things I heard from several of the people in the audience was, of course, we mentioned tape as a backup medium, but there's a massive amount of data that only exists on tape at this point. Do we migrate that in some way? Not to mention the petabytes of nearline storage that are on hard disk drives. What role do they play in the AI, spectrum of things? And what might be the solutions of the future to address the massive amounts of data that are in these other tiers?
I think this is, I was at GTC Paris on a panel speaking. I actually think there's a major reckoning coming for data and storage strategy, like I said earlier. And the reason for this, and I'll use an example of a project we recently did for a customer. This customer is they're in the media entertainment space, and they had like 50 petabytes of video sitting on a tape library, tape backup system. And they wanted to, and we actually did this project with NVIDIA, we wanted to help them start to apply AI, some VLMs, to understand and make that video searchable, semantically searchable, right? To be able to type in a phrase and say, find me the clips of video that look like this, where this action is happening. Like, imagine that for a second, right? You now have technology that can literally scan and watch 50 petabytes of video. The problem is it was sitting on tape, so they had to move that. And like, there's a lot of conversation about, well, do you move the data or not? Do you migrate it? The reality is you're gonna have to read all of that data at least one time off of tape to feed it through GPU clusters, right? At least one time. So then the philosophical question becomes, where do you discard that data after you've read it, or do you store it somewhere else to make it readable again, right? Accessible again. And a lot of this from our own personal learnings of this is that in that one project, we had to re-index that. So obviously we moved the data. We moved the data onto our system, but we had to re-index that video 6 times in the span of like 8 weeks. Why? There's just so much fast-moving innovation in the world of the models themselves, where we were getting downloads of improved models from NVIDIA every other week, for example. A lot of this requires a lot of prompt engineering. You might want to re-index things in a certain way over time. And so this philosophical debate about, do you have to move the data? I don't know, right? Like how it's going to play out, but I can tell you that in practice, you're going to end up having that data somewhere else closer and on a faster system, not than tape, for those GPUs, because you're going to access it more than one time, most likely.
Let me cut you off the way. I think summarize John's answer. That's a great answer. The answer is yes. If you're going to use AI, move the data onto SSDs, which I think, well, of course, we have a biased panel. Everyone on this panel would probably, yes, move it.
We're not at the tape backup.
Get off the tape.
So, yeah.
I'm going to be a contrarian.
Okay.
And just say, there is such a vast amount of data, no pun intended.
Thank you.
Residing on hard disk and tape. There is not enough fab capacity in the world to manufacture enough flash to put it all on SSD. So they are going to play a role in the future. It's sort of amazing. If you look at the volume, the bits shipped in hard disks today, it's more than ever, right? You don't see it on your laptop. Most of the enterprise compute platforms don't see it anymore. It's all transitioned to SSD. But in the background, at cloud scale, disk is alive and well.
Rory's bringing the truth to my dreams of storage sales. I think WD and Seagate will have some drinks for you afterward. Jay, next.
One more comment
okay.
here. So I have a lot of customers with over several exabytes of data on tape. And like what you're saying, that to move them to different media, this is impossible.
Okay.
So the new thinking here is, how do I use the AI technology embedded in the tape system, be able to harvest those information to make the tape data searchable and queryable? I think that's the trend of this. Who would know? We're going to put GPUs and high-speed memory inside the tape system now.
And to the extent possible, what we're going to see is that the metadata, the catalogs, are going to move to.
But I love this debate. This is fun. So how do you, if you infuse AI into a tape system, though, how long will it take for you to actually analyze those exabytes of data coming off of tape?
I'm going to suggest we move to the next question. But if you're a storage or tape vendor, you want to put GPUs in your box, come see me.
Yes.
Okay, Jay.
Switzerland.
I'm Bill Gervasi from Monolithic Power Systems. And I think I speak for everyone here that a body is more than a brain. And we've seen a lot of discussion about what the data centers are going to look like. But the heart, the lungs, the fingers and toes, I'd like to hear the perspective on the impact of this introduction of AI into the edge and into the client systems and into the cars. How do you anticipate the rollout and the interfacing with the 8 billion humans as opposed to the 1,000 people that are populating the data centers? with this information? How's that delivery going to be, and how is that going to impact memory and storage?
My short answer is agentic AI, but that's not really an answer. So let's go to the panel for real answers.
Yeah, I think that one thing that we are looking at that is called distributed inferencing. How do you allow us to be able to share, for example, tokens across this spectrum from edge to data center on-prem to the cloud, that be able to create this, this data fabric across all this instance. I think that will get the most efficiency because you really don't want everybody to relearn a lot of stuff. For example, that I'm creating LLM models, I'm going through the pipeline and getting all the information. Ideally, everybody, if I already get those insights, ideally I want everybody to be able to share that. And how do we share that information? How do we share the artifact of the AI result? It determine how efficient your AI project going to be.
And this is, of course, extremely forward-looking, and I don't think anyone has a true answer for you. But I would envision a future with federated inferencing. It's going to rely on connectivity, obviously. One of the aspects of AI that is a challenge is the networking aspect of it, right? There's the speeds and feeds of how you can transfer all these data across all these systems, right? And
I think
it's going to be challenging.
Yeah, I think like the network connectivity, I mean, edge is a very overloaded word, right? So you're talking about far edge at the device, you're talking about near edge, closer, like one hop from a data center with a dedicated backhaul. Like that network connectivity is going to drive, for the most part, a lot of the design decisions for the near term, right? I mean, you see a lot of this already today in a lot of autonomous vehicles. There's obviously far edge, as far as you can go into the car, where they're collecting a lot of data. Some of that is being discarded today because they're sitting on a 5G signal back to some POP, right? And so there are decisions that are just, you can't overcome the network limitations there that will drive your architecture decisions. So is there need for inferencing? It's already there, it's happening today.
Yes.
What does the data look like and the storage implications kind of going back up into the data center? It will depend on every single deployment scenario and what the network connectivity looks like across every hop.
Okay.
We have time for one more question. Anyone?
Hello, I'm Vishwas from SanDisk. I have a question around metadata management, I think, especially for vast data. How do you see this problem from database design, especially key value and relational databases, and are there any like open databases that actually solves this metadata problem that you touched upon?
So we have a database, and we actually about to roll out vector support within our database. It is proprietary. It's something that we wrote. Not that there's not good open source databases out there. We're actually in many projects using and supporting open source databases out there like Milvus and others. But we wrote our own because we obviously sell a integrated system. And so from like a supportability perspective, we have to own not own every single piece of code, but effectively own every single piece from a support perspective. I've had a few meetings with your peers about the future of different types of SSDs and its role in databases. I think it's very interesting. I mean, if you followed VAST, we were one of the early pioneers for building, like I said earlier, using QLC. A lot of that was very large I/O, sequential I/O, based off of how we leveraged it and kind of our software. But over the years, our platform has evolved and it's extended, and we now have small I/O requirements, high IOP requirements, because we're storing things like structured data for metadata catalogs, for vector databases, and so forth. So I don't remember your exact question now, but but I think from our perspective, it's kind of all blurring together, right? Because understanding and kind of the management and the usage of data has oftentimes different access patterns than just purely the storage of data, right? If it was only about large I/O, then, or like we said earlier, tape would be great, it would be done, right? But there are other things that you need and other requirements necessary in this kind of AI inferencing world.
Sunny, any thoughts about how to solve the metadata problem? I'm not sure exactly which metadata SanDisk is asking about, but thoughts? Metadata?
No, I have no idea about it. Metadata. I think that should be, presented by system perspective, not at the component level.
Okay.
Yeah.
Yeah, again, the database design going forward, a lot of optimization can be done by collaborating between the database, memory, and storage to make it most efficient. And one thing I want to go back to, not all data are created equal. To pinpoint the right data, that's where get the right data via the metadata technology, they will get the most optimal, efficient solutions.
I guess the only thing I would add to this is that, and I'm sure that VAST is considering this, one of the things that is important, particularly with metadata type applications, which tend to be fairly small items and tend to be very volatile items, commonly updated items, is that it's important whatever approach you take, you align it to the underlying storage device in terms of for the case of an SSD, you would want to pay attention to what level of write amplification you were going to be incurring with that database. And so there are databases that are media aware, and there are things that you can do there to help the situation.
Jay, thank you very. I think we're out of time, so I'd like
Yes.
to give a big thanks to our panel. So Rory, John, Vincent, and Sunny. And Jay, also, do you have any announcements?
And I was going to thank NVIDIA for coordinating this panel of experts. And I just wanted to, in closing, mention at 2:30 this afternoon is the closing panel of industry experts in Ballroom E, and it's Ask Anything. So please come to that. It's always a fun session. Thank you so much. If we can have a round of applause for our panel.
Jay, thank you. And in case, maybe you already announced, but maybe you should let everyone know, where is lunch served today? Is that in the exhibit hall? Okay.
Exhibit hall?
Okay.
Yeah.
Thank you, Tom. All right. Yes.
Thank you.
Thank you.
All righty. Oh, Rory.